What happens at the network layer? The witty way. The application hands its data to the application layer, layer 7. The data moves down the various departments in the OSI model until it reaches the network layer. The network layer checks the destination provided by the application. A determination must be made as to whether the destination is within the same subnet or not, as this impacts processing. The destination IP is 10.128.0.3. Based on the CIDR of 8, the network layer knows the local devices in the 10 network. This means the available IPs range from 10.0.0.1 to 10.255.255.254. 10.128.0.3 is well within this range. This signifies the destination device is on the same subnet. The network begins preparing the shipment. It attaches layer 3 information, which in networking terms is called encapsulation. At the completion of processing, layer 3 will have generated what is known as a packet. These two computers are both in the 10 network. We are going to monitor the behavior of traffic when devices are on the same subnet. Let's turn on simulation mode. I initiate a ping from host A towards host B. Here, we can see the layer 3 information. As you can see, the packet was successfully transmitted from host A to host B. More data has been received from the upper layers. Again, the IP is 10.128.0.3, but something has changed. The local host, with a CIDR of 9, is now in the 10.0 network. The available IPs range from 10.0.0.1 to 10.127.255.254. 10.128.0.3 does not fall within this range, signifying it is on a different network. Layer 3 begins checking if it knows of a default gateway. A gateway is a device expected to know how to move or route packets from one network to another. There is an error though. It appears no gateway has been set. With no gateway, Layer 3 begins preparing to discard the shipment. This is because Layer 3 assumes a destination in a different network is not on the same physical link and Layer 2 domain. Let's see how this looks in our lab. Host A and host B are now in different networks, and we need to reflect this in their configurations. We will change their subnet mask to 255.128 to reflect a CIDR of 9. I initiate a ping from host A to host B. If you look closely, you will see that the frame has an X on it. Why is that? The reason is that host A has determined that the destination IP is not in its network, and for that reason, it decides it won't even attempt to send it. Another shipment is being processed. Once again, the IP is 10.128.0.3. And as we learned before, that does not fall in the same range as the local device. Layer 3 begins checking to see if a default gateway has been set, and it appears one has been set this time. Layer 3 begins processing the shipment by labeling it with Layer 3 information and generating a packet. This packet will be labeled with the default gateway's information at Layer 2. Host C has been added to the lab to act as a default gateway. It is not a router, so it will not actually route any packets. Host A doesn't know that though. In order for host A to use host C as the default gateway, we must make host A aware that host C is the default gateway. On host A, I initiate a ping towards host B. As you see, the frame at host A doesn't have an X in it. This is because host A now knows of a default gateway and has processed the packet to be sent. The packet is passed down to layer 2. The frame is placed on a wire and sent to host C. As you can see, when host C receives the shipment, it has an X. That is because at layer 3, the shipment was not meant for it, and also it's not a router.